This video will cover section 5.4, example 3. And on the last video, we finished using the formula by solving for payment, and this was the formula that we had. So what we're going to do now for examples 3 and 4, we're going to be using the same formula that we derived previously. The only difference is that we had this part multiplying the present value. And of course, because it was multiplying, not dividing, the numerator and denominator were inverted. So what we can do here, let's just use that one, the one that we ended up using on the last example. So it was the payment will equal to the present value times R over M divided by 1 minus 1 plus R over M to the power negative n, and then another parenthesis here. And this one is the one to enclose the denominator. Only this part here is being raised to the power negative n. So the problem says that in October 2016, Chase Bank advertised a used car auto loan rate of 2.84% for a 5-year-old loan. Shelley wants to buy a used car for $18,700. Find the amount of each payment. So this is a great example of a problem of something that you might be doing now or considering about doing, purchasing a car. And so let's see what variables we have. We have the rate for 8.0284. Time will be 5 for a 5-year loan. The present value of the vehicle is $18,700. And let's see what else we have. M is going to be 12 for monthly. So to solve for the payment, we will need the value of the car, $18,700. And that will be multiplied by R over M, 0.0284 divided by 12. All of that divided by 1 minus, and then here we're going to have 1 plus R over M, and that will be 0.0284 divided by 12. All of this raised to the power of negative n, and remember that will be 12 times 5, so it's 60. But for our exponent, we need negative 60. So after we enter all of that on the calculator, we should get a payment of $334 with 69 cents. And to enter all of that on the calculator, you should do the following: 18,700. And then we're going to open a double parentheses. Then we're going to enter the rate, 0.0284 divided by 12. We have to enclose the rate. Then we could divide. And now we're going to enclose the denominator. So that will be 1 minus. And then here we will have 1 plus the rate again, 0.0284 divided by 12. You have to close that. Then we close again, and that quantity enclosed in the pink parentheses will be raised to the power negative 60. Remember to use the negative that is below number 3. So after that, we have to enclose the denominator, and then we have to close one more time to enclose the whole fraction. This last parentheses is taking place of the bracket. So like if that first one and this last one were taking the place of the square bracket that we have here. So if you enter all of that, you should get the payment of $334 with 69 cents. Now for example 4, we will also be calculating the payment, and now for this one I'm going to use this version of the formula. So the reason that those two formulas are equivalent is that here we have the present value multiplied by I, and you could see that I is here divided, but in reality you could have present value divided by 1, and then here you will have this quantity here, and then you have this divided by I. So I'm just going to write all of it. Okay, so if we do that and we apply this rule where you multiply the outer quantities, then that becomes your numerator. And then if you multiply the inner quantities, that will become your denominator. So that is the reason those two formulas are equivalent. So for this next problem, we're going to use this version of the formula. So, and it talks, the example 4, it talks about a mortgage loan. It says, on October 10, 2016, the average rate for a 30-year fixed mortgage was 3.37%. Assume a down payment of 20% on a home purchase of $285,000. So, find the monthly payment needed to amortize this loan. I want to say that 30-year mortgage is like the most typical home mortgage that there is. And so what we are going to do here first is take the payment of the house, the $285,000, and we're going to calculate the 20% of it because that was considered to be a down payment. So after we know that value, I'm going to subtract it from the original price of the home. So that would be $57,000. And if we now to calculate the present value of what we need to borrow from the bank for this home loan, it will be $285,000 minus the down payment of $57,000. And so this will give me a present value of $228,000. So to find the payment, like I said, we're going to use the version of the formula that has the present value multiplied by I divided by 1 minus parentheses 1 plus I raised to the power negative n. And so I'm going to substitute the quantities that I have here. So for the present value, we agree it's going to be the value of the home minus the down payment. So that will be $228,000. And we're going to multiply that by I. And here the rate is going to be 3.37%, or as a decimal, it will be 0.0337. Also, we're going to use m equals 12 because that is how the interest is calculated for a home loan or an auto loan monthly. So for our rate, we will have 0.0337 divided by 12. Now on the bottom, we're going to have, well, when you enter this in the calculator, you should have parentheses for the numerator and also for the denominator, just to make sure that you have everything in place. So this will be 1 minus, and then we will have 1 plus, and then here we're going to put the rate again, divided by 12, and then that is what will be raised to the power, and that will be n, And since we're talking about 30 years and is compounded monthly, n will equal 360. So the exponent here will be negative 360. So from here, if you enter everything correctly on your calculator, you will get that the payment will be equal to 1,007 with 35 cents. And so that will be the payment. Of course, that does not include escrow or home insurance. And just as a heads up, that could bring your payment up by maybe $300 to $500 a month. So after 10 years, approximately how much is owed on the mortgage? So what we're gonna have to do is calculate what will be the remaining balance after 10 years. So at that point, you will still have a number of payments that will correspond to 20 years, 12 payments. So that will give us a value of 240. And so what we can do here is find what the present value will be after for those payments that are still remaining. So in this case, the present value will equal to the payment, and this is a formula that we used previously on example 1. So that will be the payment, which we already found from here, 1,007 with 35 cents, and that will be multiplied by 1 minus, parentheses 1 plus, here we need the rate, 0.0337 divided by 12, we close parentheses, close again, and in this case we need to the power negative 240. And we need all of that divided by R over M. Remember, this is a formula that we used in example 1. And so from there, the present value will equal to 175,710 with 23 cents. And that concludes example 4.